Welcome to the Vitality Equation, exploring research in health and well-being one paper at a time.
Hey everyone, excited to dive into another interesting study today. What have we got lined up?
Yeah, me too. Always fascinating to see the latest developments. Hit us with it.
All right, so today we're going to be discussing a paper titled KIF5A, downregulation in spinal muscular atrophy links axonal regeneration defects with ALS. Big title, lots to unpack there.
Whoa, okay, spinal muscular atrophy and ALS. That's a heavy hitter combination. Both are pretty devastating neurodegenerative diseases, right?
Exactly. And both impact motor neurons, which are crucial for movement. So the fact that they're looking at a link between the two is potentially huge.
Right, the core of this paper focuses on KIF5A, which is a protein, a motor protein, actually that's crucial for transporting things within our neurons. Think of it like a delivery truck inside your nerve cells.
Okay, so if KIF5A is downregulated, meaning there's less of it, then the deliveries aren't getting made properly. Makes sense that that could cause problems in these diseases.
Definitely. And the paper specifically links lower levels of KIF5A to axonal regeneration defects. So axons are like the long arms of the neuron that transmit signals, and regeneration is how they repair themselves after damage. If KIF5A is low, these arms can't heal properly.
Precisely. Now, why is this significant for us thinking about improving lives? Well, understanding this KIF5A link could potentially open up new avenues for treatment, both for spinal muscular atrophy, SMA, and LS. If we can find ways to boost KIF5A levels or improve its function, we might be able to help those neurons regenerate better and slow down the progression of these diseases.
That's a great point. So it's not just about identifying the problem, but potentially finding a target for therapeutic intervention. Like, can we develop drugs or therapies that specifically upregulate KIF5A expression?
And even beyond drugs, I wonder if there are lifestyle interventions that could potentially influence KIF5A levels or the efficiency of axonal transport. Maybe specific types of exercise that stimulate neuronal growth factors, or even dietary components.
That's exactly where my mind goes. I'm immediately thinking about how we can take this knowledge and apply it to lifestyle changes. You know, it's fascinating how often we see these complex molecular mechanisms being influenced by things like exercise, diet, and stress management.
It is. So Sarah, what kind of exercise do you think might be most relevant here? We're talking about neuronal regeneration, so what comes to mind?
Well, I'd be looking at exercises known to boost neurotrophic factors like BDNF, brain-derived neurotrophic factor. High-intensity interval training, HIIT, has been shown to be really effective at increasing BDNF levels. And BDNF is like fertilizer for the brain, promoting neuron growth and survival.
Yes, and there's research showing that aerobic exercise, like running or swimming, can also have a positive impact on neuroplasticity. The key is finding the right balance, you know? Too much intense exercise can actually be detrimental, so it's about finding that sweet spot.
Right? So the intensity and duration are key. But it's interesting to think about how exercise could, in theory, influence the expression of a specific protein like KIF5A. Do we have any evidence that exercise can actually do that at that molecular level?
Well, we know that exercise can influence gene expression in general. It's not a stretch to think that it could potentially impact KIF5A expression as well, although I'm not aware of any studies that have specifically looked at that. But that would be an incredible avenue for future research.
Absolutely. And thinking about diet, there are certain nutrients that are known to support brain health. Things like omega-3 fatty acids found in fish oil are crucial for neuronal membrane structure and function. And then there are antioxidants, like those found in berries, which can protect neurons from damage.
Okay, so we're talking about creating an environment that's conducive to neuronal health and regeneration. It's not a direct eat this, increase KIF5, a kind of thing, but more of a holistic approach.
Exactly. And let's not forget about sleep. Sleep is when the brain clears out toxins and consolidates memories. Poor sleep can impair neuronal function and potentially hinder regeneration. So optimizing sleep hygiene would be crucial for anyone trying to support their brain health, especially those at risk for neurodegenerative diseases.
Yes, sleep is so vital and so often overlooked. You know, I've been incorporating more mindful sleep practices into my routine. focusing on creating a calm and relaxing bedtime environment. It's made a huge difference in my sleep quality.
That's interesting, Jesus. So in the context of this paper, if KIF 5A downregulation is linked to axonal regeneration defects, and axonal regeneration is vital for neuronal health, then sleep is crucial for axonal regeneration as well. So indirectly, sleep is critical for KIF 5A's proper function. Does that sound right?
That's a good way to frame it, yeah. It all connects. It's funny how often we talk about these things in isolation. Exercise, diet, sleep, but they're all interconnected and influence each other.
That's exactly it. It's about creating a synergistic effect, combining these lifestyle factors to maximize their impact on brain health. And I think mindfulness and stress management play a huge role in that as well.
Okay, hold on. Let's delve into the mindfulness piece. So if we're thinking about ALS and SMA, these are diseases that create a huge amount of stress and anxiety for the patients and their families. How can mindfulness techniques potentially help, specifically in the context of this KIF 5A finding?
Well, chronic stress can have a negative impact on brain health in general. It can increase inflammation, disrupt sleep, and even impair neuroplasticity. So, by reducing stress through mindfulness practices, we can create a more favorable environment for neuronal function and potentially support the function of KIF5A.
And mindfulness can also help people cope with the emotional challenges of living with a neurodegenerative disease. It can help them cultivate a sense of acceptance and resilience, which can improve their quality of life, even in the face of significant physical limitations.
That resonates with my perspective. Mindfulness-based cognitive therapy, MBCT, could be really beneficial, helping patients to manage their thoughts and emotions around the disease, reduce rumination, and focus on the present moment. All of that can reduce the overall stress load and potentially improve neuronal health.
Exactly. And there's research showing that meditation can actually increase gray matter volume in the brain, which is a sign of increased neuronal density. So it's not just about reducing stress, it's also about actively promoting brain health.
That's amazing. So it's like a multi-pronged approach. We're addressing the physical aspects of the disease with exercise and diet, the emotional aspects with mindfulness and CBT, and the sleep aspect with improved sleep hygiene, all with the aim of supporting KIF 5A function and promoting neuronal regeneration.
Yes, and let's dig a bit deeper into the cognitive aspect. This paper links KIF 5A downregulation to axonal regeneration defects, which is a key word there. So, if these motor neurons are damaged due to impaired axonal regeneration, can we use cognitive exercises and therapies to compensate for this loss? Could we retrain the brain to use alternative pathways or strategies?
That's a really interesting question. It's like, if the main highway is blocked, can we create detours and back roads to get to the same destination?
And that's where physical therapy comes in too, right? Helping people learn new ways to move and perform daily tasks, even with impaired motor function.
Exactly. So, let's say someone with SMA is having difficulty with fine motor skills due to axonal damage. We could use CBT techniques to help them break down complex tasks into smaller, more manageable steps, and then use positive reinforcement to encourage them and build their confidence. It's not necessarily fixing the underlying neuronal damage, but it's helping them adapt and maximize their remaining function.
Yes, and even things like adaptive tools and assistive technology could play a huge role, helping people maintain their independence and quality of life despite their physical limitations.
And that's so important for maintaining a sense of agency and control, which can have a huge impact on mental well-being. Feeling like you're still in charge of your own life, even when your body is failing you, is crucial.
Absolutely. So to summarize, we've got this paper identifying KIF 5A downregulation as a key link between SMA and ALS. We've talked about how this understanding could potentially lead to new drug targets, but also how we can apply lifestyle interventions like exercise, diet, sleep, mindfulness, and cognitive therapy to support neuronal health and potentially slow down the progression of these diseases. It's a holistic approach, addressing the physical, emotional, and cognitive aspects of these conditions.
Yeah, and I think it's important to emphasize that this is not a one-size-fits-all approach. It's about tailoring these interventions to the individual based on their specific needs and circumstances. What works for one person might not work for another.
Exactly. And it's about empowering people to take control of their own health and well-being, giving them the tools and knowledge they need to make informed choices and live their lives to the fullest, despite the challenges they face.
So, looking forward, what are some potential future research directions that stem from this paper? Where would you guys like to see this research go?
From my perspective, I'd love to see studies that specifically investigate the impact of lifestyle interventions on K, I, F5A, levels in axonal regeneration. Can we design exercise protocols, dietary interventions, or mindfulness practices that can demonstrably improve these outcomes in people with SMA and ALS?
I'd be interested in seeing research that explores the optimal timing and dosage of these interventions. When is the best time to start exercising? How much exercise is too much? What are the ideal sleep patterns for promoting neuronal regeneration? These are all crucial questions that need to be answered.
And from a cognitive perspective, I'd like to see studies that investigate the effectiveness of targeted CBT interventions in compensating for axonal damage. Can we develop specific cognitive exercises that can help people retrain their brains and maintain their function despite the underlying neuronal loss?
Yes, and I think it's important to remember that this research is not just relevant to SMA and ALS. Understanding the role of KIF5A in axonal transport and neuronal regeneration could have broader implications for other neurodegenerative diseases, like Alzheimer's and Parkinson's.
Absolutely. It's all interconnected. The more we learn about the fundamental mechanisms of brain health, the better equipped we'll be to tackle these devastating diseases.
Well, this has been a fascinating discussion. It's always inspiring to see how research like this can potentially translate into real-world improvements in people's lives. Thanks for sharing your insights, everyone.
Thank you both. It's been a pleasure as always. And thanks to our listeners for tuning in. We hope you found this discussion informative and inspiring.
Yeah, thanks for joining us. Until next time, take care and stay healthy.